So we'll now move on to our next presentation. Brian Coleman is the advisor for the Somerset High School solar car team in Kentucky, but he was previously the advisor of the Bath County High School solar car team, the Kentucky Solar Cats, and they participated first in 2019. And so he's going to talk to us a bit about the importance of reliable mechanical diagrams and schematics. And I believe he's visiting over with Greenville, and so you'll see him listed under Joel. Hey, Brian.
Hey, how's it going?
Doing great. Thank you for presenting, and it's nice to be able to visit with somebody live, right? With
yes,
the Greenville team.
Oh, they're very kind to host us. Okay, so first off, I'm Brian Coleman. I'm with the Somerset Solar Jumpers. That's in Somerset, Kentucky. It was originally for the past few years at Bath County in Bath County, Kentucky. They were the first solar car team out of Kentucky, started in a race for the first time in 2019. 2020 shut down, of course, and we raced again last year in 2021. Then I was asked to come over and start a solar car program at the Somerset High School, and this is where we are. And Dr. Marks asked me to come in and talk about the importance of mechanical diagrams and schematics. And I think he gave us a little more credit than probably we deserve, but the reason he asked that is because the Bath County team, the second year, actually won the mechanical drawing competition for the Classic Division, and that's due in no small part to the work of about 3 or 4 of the students there who decided to pick up the Solid Edge software and basically run with it. And they took it much further than I had anticipated they'd be able to do for the first year. So that being said, if you are new to CADing or wanting to get into using Solid Edge, maybe switching from a different program, my background's in Autodesk products and some Onshape and stuff like that as well, but we switched over because they're a sponsor. It actually, the learning curve is not too bad. And when students can switch over that quickly and make the quality of projects that you're going to see in a moment in just a matter of a couple of months, I think you might consider giving it a try. All right, first year lesson learned. So what this is going to be is, so the very first year that we ran in 2019, we kind of did everything exactly backwards from what you wanted to do. So we started with started just building a frame. You're really eager, you're excited, and you get in there and you start building the frame. And we actually started with a roll bar and started building the frame out from that with very little, if any, thought to actually how everything was going to go together. We wasted so much time and we spent so much time, and you'll notice the first lesson learned is constantly in a build or rebuild cycle. It massively, hang on, let's see if I can move this stuff so it massively increases your frustration level, your time, and stuff like that. So the second one there, so you have a significant loss of time. Many extremely late nights and mornings were caused from this. We were literally working because we were having to, we build something, put it on the car because we didn't really have a real good idea of how that was going to work with everything else because it is a system. They ended up realizing they had to cut it off and start all over again. And it caused us to work until 2:30, 4:30, 6:30 in the morning sometimes just trying to get the car ready so that we'd be able to race. Being the first team in Kentucky to ever try this, they kind of put themselves in a situation to where if they didn't do this, then there were a lot of naysayers, let's just say that if they weren't successful that year, they put a lot of pressure on themselves to actually be able to complete this. And so because of that, it caused a lot of late nights. There were days that we had to go and we were supposed to be having a media event going on and the car wasn't ready and we were literally cutting big sections off the car and trying to get them back on. It was just a complete nightmare. So you lose a lot of time of that. The reduction in time also then increases your speed at which you have to do production, which then causes for poor efficiency of design and when you're doing that as well. So your quality drastically go down. And the biggest aspect was this, not only was the time, but we lost lots of money doing this because we kept having to rebuy parts. We probably purchased enough metal to build 3 vehicles that first year. So I cannot stress enough the time that you will put in for doing your design up front and making sure that everything works with one another and doing some other things that we'll talk about here in a moment is well worth it. I tell my students all the time, I liken it to painters. If you're going to paint a house, you know, you can take the time If you're smart, you'll take the time and you'll tape everything off, you'll mask everything off that you're going to do. And you think that you're wasting time up front by doing all those things, but in reality, you speed up the end process and you get a better quality product at the end. Benefits. Division of labor. So when you have a high quality CAD drawings, and what we have decided and realized from this is that waiting till your entire CAD is finished is not necessarily required per se. What we do is we basically take the car and we break it into different sections. So we have like our front end suspension system, we'll have our rear end suspension system, we will have our safety components, which will be frame and crush zone and roll cage. We will have things that are related to our electrical, and we break those into different sections. And you will have students basically working on different parts of those and making the individual portions, as opposed to what we did the first time. We tried to draw the entire car in a single drawing. So there were not individual components for this. So the issue was anytime that there were changes, you had to go back and redo everything because it was all tied to itself. This is production time because you have multiple individuals working on even the CAD itself. It also reduced the production time in the actual parts, because once you finish and have the actual mechanical drawings completed and you've tested those and done analysis and so forth, you can actually divide those components up into various teams or individuals for them to work on simultaneously. And if you've done the work ahead of time, you're in pretty good confidence that they're going to be able to relate and connect with one another when you actually get finished. Increased quality, because you get to go a little bit slower at the production of those components. You get to pay attention to what you're actually producing. Increased efficiency. If the quality of the products are better, you actually get a better product in the end, and overall, your efficiency of your design and your car and the functionality of it increases. Reduced costs. The second cost, the year in 2021, when we built that second car, first off, our time went down to probably about a third the time to actually build the car. The second is, if you had seen, and I'm sure you remember, the first car from 19 to 21, there was a night and day difference between the design of those two different cars. The first one we actually called, it was a tank, and it looked like a minivan. It was the only really redeeming factors. It had a nice little graphic on the side of it that Dr. Marks and he laughed at every time it went out on the road. Our brakes were rubbing, they were out of alignment. The steering was horrible. You'd turn and it'd dip in the entire car would dip. I mean, I could go on and on. But to give you an idea, by the time we came back, it's a 2-day trip back from Kentucky, we had 40 different items that needed to be repaired on the car that the students had identified themselves. They had to entirely build the car anew for the 2021. Increased parts fabrication accuracy, we've already mentioned that. On the screen, you'll see a couple of different items there. Those are actually drawn in solid edge. And when I say that you get a better quality and that from that, it's because these items here, for example, are actually fully have the ability to articulate. So these are actually functioning parts when you actually put them in the CAD program. So the master cylinder that you see there, which is an MCP master cylinder, is to the specifications of that actual cylinder that is on the car, and it actually functions when we put it in our assembly products for that. So they can actually see whether or not it's going to run into another area of the car, if there's going to be an issue in one place or another. That's actually a wheelwood caliper that's there that's actually functioning when we put it in as well. Additional benefits: increased ease of assembly. When you have these designed correctly, and even though you have divided the labor up and everyone's working on different sections of the car, literally in different parts of the shop, if you've done this correctly to the level of expertise or expectations that you have, when you come together and put them together, you have very little adjustments that need to be made when you're doing assembly. Improved safety. I just mentioned that the car we did in 2019 had massive steering issues and braking issues and all kinds like that. The second car that we have, I had no trouble taking it out on the highway and actually driving it full tilt without any reservations. I always took the car out whenever we did a major change in suspension, steering, or something like that, before the students took the car out, and I would put it through its test. And I tell them up front, my job is to try and break it, because first off, if I can break it, then something's not right. But I would have no problem or hesitation allowing the students, after we learned this process from the first year and how important of having the mechanical drawings and wiring diagrams were, of going out, testing it, and getting up to speed, full tilt, and then turning it over to students and letting them drive it hard as well, because we knew then that the car was safe. And I was pretty confident going out to begin with. Increased speed of instruction and learning. When you do this, one of the items as the first year team, we've had, I don't remember what was the gentleman's name that spoke about starting a team? Robert. So Robert spoke about starting a team. So we were a new team as well. One of the things that you'll have to deal with is getting your students up to speed with the technical aspects, the project planning, everything that goes with that. The nice thing that we realized from the first year to the second year, and we had a lot of people graduate after the first year, so it was like having a new team even that second year, is that when you did this, you actually had something that you could use for better instruction for them, and that learning curve was drastically flattened for those new individuals coming in. We also implemented, along with that, was an aspect of those individuals that were forward became mentors to the new ones coming in. And that sounds nice in theory, but it's not helpful if they don't actually have something to show those individuals. Like when I'm talking, and there's nothing in front of them. Remember, we built the car again from scratch. And so having the CAD, the mechanical drawings, and the wiring diagrams there in front of them actually helped them get the actual product built much faster. Clear visual representations. You're going to have to turn in here on March 1st, you have to have all your documentation into them by March 1st. You're going to send a digital copy of your wiring diagrams, your schematics, your CAD drawings, and all the specification sheets that goes with pretty much everything with your car and a bunch of other things. Make sure you read the rules for that. When you do this and you send this to them, the judges and the individuals for Solar Car Challenge are actually going to take a look at those, and they're going to make sure, first off, there's not anything major. You're going to have all your products in there, but it helps them a great deal if what you're sending them is clear and easy to read. In addition, not only there, but also when you actually go to scrutineering, we found that ourselves and the Iron Lions are honored to have been the only two teams to actually pass scrutineering this past year on the first day. Complete shock to us, trust me. But I honestly believe that's not due in any small part to the quality of the CAD drawings that were presented, done by these other students, and the wiring diagrams, which I'm going to show you here in a moment. Because when the judges actually looked at those, when they were evaluating what they had, it was literally laid out right then for them. They didn't have to hunt for anything. It was very easy, and it matched exactly what was sitting in front of them. The car and the diagrams and the schematics all matched exactly down to literally almost down to the millimeter. The virtual testing and analysis. In some of the software, especially in the Solid Edge that we have, and if you don't know, Solid Edge also offers academic grants that you can get a lot of other software besides the basic Solid Edge package. And if you get online or give them a call, they will tell you, and there's it's literally tens or not hundreds of thousands of dollars worth of software they'll give to students. One of those items in there will allow you to do stress analysis on the vehicles themselves. So you literally can choose what material you're using, what size it is, actually do the CAD drawing out, and you can change it on the fly. Just simply change the material, and then do a test analysis and determine whether or not where you're putting your loads on the frame or the structure, or what like that. And it will give you an analysis of that and tell you whether or not it's a weak spot and whether it's overbuilt. Or whether you need to, what you need to do there. So that's kind of a neat aspect as well. You can additionally, which we have not done this part yet, but there's another package that you can get, which allows you to bring in all of the electrical components as well, the wiring, the electrical components, the switches, the relays, the battery systems, whatever, for actually developing wiring harnesses. And it will then do a test for that to make sure that you don't have any shorts, missed wires, that all of your electrical components are matched to one another to have a nice, safe wiring harness for that. That's actually our next phase that we're going to be doing for that. Detailed documentation, we talked about that before. You're going to need that for the Solar Car Challenge. Again, you'll see on the screen there very quickly, diagrams, CAD drawings of aspects for the car that they're actually using for this year. These are a few examples. These are the actual drawings that were turned in from the Bath County team for that year that allowed them to win their division. I fully expect that there are going to be diagrams coming from schools this year that are going to, let's just say, step it up. And so it's going to be even more challenging. But in these diagrams, if you look at this, you'll notice that there's dimensioning everywhere. You'll notice that they have, what is this stuff, human Make human, the make human character inside there. What we did was every individual that was capable for or may potentially be a driver, there's a make human character for them. That's not a generic one that we simply drop in. We literally put in all of their dimensions, literally from their biceps to their weight, their waist, their height, everything, and put them in. And we took basically the tallest individual seated and place them in there. And then we'd also put the one with the longest legs, and we put them in for the dimensions for that as well. And these dimensions in here actually match the people that are actually going to be in the car. Here's a side view, which is also required. And the key portion of this is twofold on this one. This one here represents more than anything else, that 10-degree viewing angle that is required. And that then we drew this in so that we could determine how high and what position our solar array had to be in relationship to the driver and also to the front of the car. Because what we're attempting to do here is we're attempting to get that down as low as possible to lower our center of gravity. But we also can't come, if we do that, we get into the 10-degree angle. So it has to be at a certain height without coming back. And because we're maximizing, we're at 4.94 of the 5 meters there, we really can't allow the front end of our solar array to come back behind the front end of our car. Otherwise, our entire vehicle ends up being too long. By having the CAD drawing here, it allowed us then to actually get all of our diagonal support braces measured out exactly. So we'd know that then determined what size of material we were going to use to make sure that they didn't flex too much or so forth based upon the weight of the solar array themselves. The other item on this is you'll notice in red that, but first off, there's 3 colors on here. You have a red section, you have gold, and then there's gray. The gray is actually the roll cage itself. The gold is the roll bar, and the red represents the crush zone. When you send your packaging in for the documentation, they're going to want you to identify in some form or fashion those 3 main components so that they can make sure that you have proper spacing and so forth, and all the other rules that are related to that. What we found was the easiest way to do that is to identify that with a colored drawing diagram. This is the top view where you can see the same thing for those, and you'll see that. And then here is the rear view. And I don't think I need to go over all the rest of that.
Okay, can I jump in real quick and emphasize 2 points that you just made from a chief judge perspective?
Please.
You had pointed out the 10-degree thing. Oh, sorry, turn my video back on. You had pointed out the 10 degrees. I can't tell you how disheartening it is when I have to tell a team that they can't compete because they don't comply with that rule. This is for first-year teams and even some of the returning teams. There is zero give on this because for a road race, that's how we determine that you can actually see with reasonable ability a stoplight that's going to be up above you when you come to a stop. So this rule is critical. You will not be allowed to participate in the event, excuse me, unless you can actually meet the 10 degrees. And I can't emphasize enough how important it is to be able to do this ahead of time and know that your design is going to comply. It puts you in a position that you can actually have some confidence before you get to the event. And actually before you build your car and make adjustments in virtual space, which from personal experience, I can tell you virtual space adjustments are much easier than physical space adjustments when you're now talking about cutting and rewelding. The second one is a few slides ago, you were talking about the human models that you're using and the sides to it. This is another thing. There's a couple parts of my job as the chief judge that I don't like, and it's usually when I have to tell things that are things that are unfortunate. The other big one for me is when I have to tell a driver that they don't comply with the minimum clearances. So even though it's their senior year and they put their heart and soul into the car, they can't drive it. So I would also emphasize and ask that everyone double and triple check for all of your drivers that you have those minimum clearances and that you fit adequately in the car, because that is another thing that will prevent you from participating in the event. To the point that I've actually had teams who have had 1 or 2 drivers be unable to use them and then had to go to other teams to ask for drivers to drive their car. Again, because of the kind of lack of planning that went into the cockpit as they built it. It was an afterthought instead of a design consideration. And I'm not saying this stuff to try and scare or intimidate. That's the last thing I want to do. It's to give you guys some guidance ahead of time and help highlight some things that are really important and common catches that we have with new teams. So again, please, please, please double check, put some thought into clearance for the driver, and absolutely the 10 degrees has to be there. It's not a rule that you can just get a failure to comply penalty, lose a couple of miles for it, and move on in life. This is a, you're not allowed to participate because we don't think you can adequately see, and it's a safety issue. This just goes ahead again and shows you what great things you can do with planning ahead of time. The more detail you put in what you present to us, it's also the more likely that when we pass over it and review it, we can potentially catch an issue like that and tell you about it way ahead of time. Again, it's never our goal to punish or to be difficult with teams. I know most of the teams that have worked with us over email in the past, hopefully it hasn't been truly horrible experiences, but a lot of teams have come to us ahead of time and asked, is this okay? And just pointed it out ahead of time. We're not sure if this complies, and we'll work with you on it. But if you don't document that stuff, you don't tell us about it, and then we have to deal with it in scrutineering, you're stuck in a place where we can tell you, no, that's no good, and you don't have enough bandwidth there at scrutineering to go and fix it, enough time left, or the materials, or whatever it might be. So I can't overemphasize the importance of doing this and just being open with us, and we'll be open with you in return. All right, thank you. I'll step off my soapbox now. That was just a couple of gotchas I wanted to highlight. So thank you.
Yeah, and talking about the 10-degree rule and the human model, there was a question that came in asking where you got the model for the human in your drawings. Could you talk about that, Brian?
Yes, this is something that most experienced teams have heard about at one time or another. But if you're new, there's a program called Make Human. You can just simply go online. It's a program called Make Human. It allows you to put in the dimensions of the individuals, and you'll be able to export that and then take it into, I think we used Blender. Is that correct, gentlemen? Yes, we take the model out. It's going to come out looking like one of those little straight leg, straight arm little characters in Make Human. But then you take that out and import it into Blender, and you can put it in a seated position or whatever other position you need. And so we positioned it with the legs like that and the arms so that it actually matched that seat, the angle on that seat. When I say these are precise drawings and components, that seat actually matches the exact seat that is that we use with the reclined angle and everything. And so they place that in there. And if you'll notice, if you look where the eye is, there's a certain height, and you can let you read the rules, but in reality, it states that it has to be at least 70 centimeters from the ground minimum, the eye height of the individual for that. But please always double check the rules, never take an individual's word for that. You'll notice that if you follow the line up at the angle, that from the bottom of the solar panel, which is correctly sized to 1.5 inches, which was the frame for that solar panel, that there's a space between it and that line. My recommendation is, you're free to do whatever, but my recommendation is that you leave yourself a little cushion there for that, just to make sure. If you cut it too tight and somebody all of a sudden gets these are teenagers we're talking about, if they get a growth spurt for whatever reason, or I don't know, maybe they put a wallet in their pocket, they forget, and it raises them up by 1/2 inch, you may find yourself disqualified for some reason as a driver. So I just made that up, but I mean, do double check and always leave yourself a little bit of a cushion. For example, there's a 5 centimeter requirement between the bottom of the roll bar. Actually, it's not the bottom of the roll bar, it's the bottom of whatever is there. So if you have a cushion, like a padding around the roll bar, it's from that to your head. And the only reason I know that is because they're correct. If you have a question, send an email to them, they'll respond. We had a question about that last year. Is it from the bottom of the roll bar or from the bottom of the cushion, the padding that we put around that? It's actually from whatever that padding is or whatever is there that Dr. Mark says that has to have that minimum clearance. So if Mr. Jones has any variations on that, he's more than welcome to fill in on that.
No, I think you said it really well. Thank you.
I'm going to finish up here with the wiring diagrams. And the reason I'm going to finish with the wiring diagrams is because this is one of the things that for us, well, for me, I thought was one of the most valuable things that we did. We talked earlier that some of the benefits is that it increases learning for students if you have good schematics and wiring diagrams. So, you know, if we go back here, it's really easy for you to, I mean, the best method is to have a car in front of you, but if you're teaching new students or mentoring other individuals and you have these right here and they're fully labeled and they're accurate to what they're actually going to see in front of them, that's very helpful. Well, when we get to the wiring diagrams, this is about keeping everyone safe and knowledgeable. This is our wiring diagram that we used last year in 2021 for the low voltage. And when they were talking earlier, Mr. Pitts was talking about getting the wiring that he could order that, and it comes in all the different colors for that. These colors actually match the colors that were on our car. And we did this, now obviously you see the wires going outside, but what we did was, if you'll notice, this is all this is low voltage and all of the wiring goes on the left-hand side of the car. It comes across the dash and it goes down the left-hand side of the car. We did this because our experience was with the track. And on the track, when you exit the car, you exit to the left side of the car. When you enter the car, you enter on the left-hand side of the car, the driver does. So for us, and you're going to see in the next diagram, we put all of our high voltage on the right-hand side. So our high voltage and low voltage lines were never running beside one another at any time. And so we determined that if a student were to inadvertently get into wiring, which was difficult because we had it in conduit and everything else, it was all secure like that. But we decided to put all our low voltage on that side. In addition, your low voltage system is going to be required. And again, for those who've been doing this, I'm preaching to the choir, so to speak, but you're going to have to maintain your low voltage battery system to make sure that your safety items, as in your horn, your turn signals and so forth, are running all the time. And you may from time to time have to change the battery from that in order to keep your safety low voltage systems running. That's on that left-hand side as well, which makes it easy. If you come out there, you come in for a pit stop and say, hey, I need to switch a battery. It's right there. You're not having to try and go around to the traffic side for that. And then this is our high voltage system that we use, and it's all on that side. Now, it's all on the left-hand side for that. Now, however, after being here today with the Iron Lions, one thing that you may want to take into consideration, which we hadn't considered until we were chatting here, is that you may want to reverse this for a road race. And the reason being is that when you're going to be driving on the right-hand side of the road, if you need to get out for safety purposes, on a single seater especially, you need to try and get out on the right-hand side because that's away from traffic, which means anything that you're going to do related to your electrical and stuff like that, you might want to make it handy by putting it on that side. It's entirely up to you. I don't think there's a rule regarding that, but I try and fall to the side of being safe for the students. So we have a rule. They have the guidelines. We try not to skirt those as close. I have a friend that's a minister that used to talk about, he lived next to the water treatment plant, and they call them the poo pipes, where the stuff goes through the pipes like that there. And they, on their way to work or on the way to school, the students would try and walk these round pipes, okay. And so on one side, if they fall off, they fall into where all the mess, let's just say that stuff there. And so they would sit there and try and see just how well they could do, how close they could get to it without actually falling into the poo. The problem is when you do that, eventually you're going to get the poo all over you. And so if you skirt the lines too much in the rules, you're probably going to get burnt or get dirty at some point or another. So my recommendation is leave yourself a little bit of cushion, and when in doubt, fall to the side of safety for your students. And any questions?
There's a question that was asked online. Could you remind me of the software that this is drawn on?
Solid Edge, Siemens Solid Edge.
Okay. I had a question. You were talking about how these individual parts, let's say the MCP brake caliper and stuff, even had it so you can articulate. So, yes. And you can do some virtual testing with it. How much and what type of simulation or virtual testing did you do before you started fabricating your vehicle?
Pretty much what we did, because, all right, so I'm going to go back to what I was just talking about on skirting the lines. So our first car, our rule was, because we had heard the horror stories of individuals going to scrutineering for 1, 2, 3 years, and because they didn't read the rules carefully, they would basically not pass scrutineering, then would have to go home. Well, being a first team from Kentucky and having a 2-day trip to come down and very limited budgets, we were like, we can't afford to do this. We have to be successful. So our rule was on the first car, which is why it was massively overbuilt, 1,246 pounds worth of car. Massive 2-inch pipes holding, I mean, it was a mess. Because of that, though, that the guideline there was, we want to, whatever you do, when in doubt, go the next level. And so when you do that throughout an entire car, you know, it gets massive and massively overbuilt. So the second car, we realized, you know, we did that a bit too much, too excessive. But we also didn't want to make sure, so we wanted to make sure that we came down closer to not the minimum, but a safe margin within whatever the rules are for that. So when we took those items and we put them in, we would articulate them. So for example, the width of the driver compartment on the first car that we had was actually 42 inches inside the driver compartment for a single individual. And anybody who's been inside one of these knows that's a lot of room. So the second car went down to 28 inches on the inside. So when you start doing that and you're having like we'll talk about the master cylinders. We're in there and we're trying to then make sure that we have room spacing for the 6 inches and the 3 inches and so forth for the spacing in there. Then your pedals are going to be moving, your brake pedals are going to be moving, and your master cylinder rods are going to be moving as well. We wanted to make sure, one, that they weren't going to come in and be a safety issue for the individual, but also that they weren't going to hit another part of the car, because we're starting to bring all these things closer and closer. The spacing between parts and framing materials starts getting tighter and tighter in that environment. And you could very easily, if you're not carefully, say, okay, we built that frame, and then you go later and simply just stick the this master cylinder on there, or a pedal that's about 8 inches long, and it's going to have an articulation range, and you run into something else that then causes another problem because you simply can't depress the brake to its full extent or something of that nature. So when we're doing those, that's what we would do. We would move anything that articulated or moved. We would make sure that it didn't impinge upon another component of the car. Brake lines, for example, to make sure that they were going to be out of alignment, out of place when you're actually then turning the wheels, to make sure that you could get the turning radius for that.
That's great. I think that really gets you to be sure that when you actually started building and putting things together, that you don't run into, oh, oops, we missed this or missed that. So that's great. I want to remind everyone that the Siemens Solid Edge folks will be coming to present during this workshop tonight at 8 p.m. Central. We will hear from Siemens on how to draw the mechanical drawings, and then tomorrow at noon they will come and present on electrical schematics. And so you know, this was a great presentation on why you would use it, the things that you learn from it, and then you'll get a bit more hands-on presentation on how to use that Solid Edge software. So thanks, Brian, for the presentation.